Welcome to topic 7 of data science, and topic 7 is on correlation and also Pearson's R. Firstly, what is correlation? Correlation or correlation is the degree of association between variables or a measure of the strength of that association. I've got a couple of graphics here, one slightly more pixelated than the other. I'll need to probably fix this RAM one here. But we have two examples. So the first one is we have a sunny day, which is very rare in Scotland. So because of the sun, we have two things that might happen. So two causations, okay? The sun is causing these two things to happen, all right? But because of that, there is a relationship or an association between these two, and that is called the correlation, okay? So you could say that hot, sunny weather, okay, increases sales of ice cream, and sales of ice cream are related to levels of sunburn, okay? Or you could say that they are correlated, okay, or correlated, as it's more often pronounced. All right, so the other example I've got here is we have a correlation between your phone freezing and text messages not working, okay, and the cause of that is the lack of RAM. So, correlation coefficients. A correlation coefficient is used to measure how strong a relationship is between two variables. So it's all very well saying, you know, sunburn is correlated to sales of ice cream, okay? But, can we measure that? Can we say by how much, to what degree that is? And the answer is yes, we can do that. And we can do that using a thing called Pearson's R. Okay, so Pearson's R is the most common type of correlation coefficient. There are other ones, but when people are talking about the coefficient, they're most often referring to Pearson's R. Okay, so Pearson's R gives us a number, and this is very common to use in statistics. So how do we actually find a correlation? Well, in order to find a correlation, we have to answer the question, is there a relationship between two variables? Okay. Is a person's height associated with liking beer or wine? So that's maybe just a silly example, Is the time of day associated with liking a particular food? Okay, so we're taking two separate variables and we're trying to establish if there's a relationship between them, and if so, to what degree that relationship exists. So if a relationship exists between two variables, then can we measure the strength of that relationship? And the answer is yes, we can. And the strength of that relationship is measured using a correlation coefficient. Okay, now a coefficient is a number used to multiply a variable. So if I say 6z or 6z, this means 6 times z, the product of 6 and z. Okay, the product just means multiplying the two things. So z is the variable and 6 is the coefficient. 6 is the number of times we're going to multiply that. Okay, so the strength of association, the strength of a Pearson's R correlation ranges from -1 to +1. Okay, so it's always a number between -1, 0, and +1. Okay, it's never greater than 1, it's never less than -1. And once we calculate this correlation coefficient, we come out with a number. So for example, if I said that something had if something correlated at 0.5, that would indicate a positive correlation, okay, a moderately positive correlation, okay. If I said something correlated at 0.9, that would be a very, very strong correlation, and +1 is a perfect positive correlation, okay. And likewise, the same works in the negative direction, okay. So negative 0.5 would be a moderate to low negative correlation, all the way down to -1. So that's our range. We have the strongest agreement and the strongest possible disagreement, okay? So if I said to you that something correlates at 0.3, you'd think, okay, so there is a moderately positive correlation. So as something increases, there is a moderate increase in the other related variable as well, although it's not an incredibly strong correlation as something like 0.85 or 0.9 would be. So when people say things correlate at 0.4 or correlate at 0.5, generally they're talking about the Pearson's R coefficient correlation. Okay, so think about if we have variables in a table or entries in a table, like in an Excel spreadsheet. If we have an X and a Y variable and we plot these out, okay, sometimes we can see what's called a linear relationship. Okay, so the linear relationship that can exist. So if you imagine if up here, okay, is sales of ice cream, and along here is sales of sun cream, we have what's called a positive linear correlation, okay? Likewise, up here would be sales of ice cream, and this way would be maybe sales of umbrellas or sales of raincoats, which would be a negative relationship in that direction. Okay, so those are two kind of simple ones. There are some other ones. There's an independent correlation. Okay, so this here means that there's not really any, we can't really find any relation between these variables. Okay, they're just all over the place. This shape here and this shape here is called a curvilinear relationship. It just means a curved line. Okay, so that's a bit of an introduction to some of the terminology. So let's now look at an example of how we would actually work this out. So what I've got here is I've got a hypothesis. So that's a statement that I'm going to make. Okay, and I'm going to say the number of hours spent studying for an exam is positively related to the final grade for that exam. So what I'm proposing, my thesis here, my hypothesis is that the more you study for an exam, the higher the grade that you're going to get. So we have two variables there. We have hours of study and score on exam. Okay, now imagine if we calculated how much time everyone in the class studied for an exam. Someone might only study for 1 hour. Someone might study for 25 hours. And when we take that whole range, okay, let's say we came up with an average time studied of 4 hours and an average score of 60%. Okay, these would be mean values on both. Now, let's say we wanted to determine if a relationship existed between the number of hours of study and the exam score. To do that, we could calculate Pearson's R and measure the linear relationship between two variables. So how strong that association is, we could measure that. So here is a simple data set that I've put together. Consider this, right? We have the results of 2 tests for 5 students. The tests were marked out of 10, okay? and the values were placed in a table. So this is just a simple data set that I've put together. We have a maths test here, scores out of 10 going along here for each student, and then an English test, okay, and scores again going along here. And if you imagine another row where these are the student numbers, so student number 1, student number 2, student number 3, student number 4, and student number 5. So we have 5 records, and we have a result for each. Okay, so these results are sometimes referred to as observations. Okay, so we got 10 observations in total, and we can consider these to be variables. Okay, the maths result and the English result. Okay, so let's move forward and look at how we can use this information to see if there's a relationship between these two pieces of data that we've collected. So given that I could calculate this, I would be able to say, based on your score in the maths test, how likely that is to be able to predict your score in the English exam, or is there a relationship between the two? And if so, how strong is that relationship? Now, I just made these numbers up deliberately to kind of show that this is just an example. But imagine if we had an actual, very large data set. I've also made this small, and I've made the numbers small so that we can see it worked in a simple example. So let's take this data set and add something to it. So what we're going to do is, the other name for the Pearson's R is called the product moment correlation coefficient. So we don't call it the product moment correlation coefficient all the time, because that's a very long thing to say. It's just called Pearson's R. And the formula for Pearson's R is shown here. Okay, so to calculate R, we need to work out this formula here. Now, in order to work out this formula here, we need to first of all learn what each of these things are. We need to learn what n is, we need to learn what x is, we need to learn what y is, okay? Hopefully we already know what minus is, and then we need to divide that by the square root of these values on the bottom. So what we're going to do first of all is calculate our x and y variables. So I'm going to add something to the table first of all. So here's that same table, and what I've done is I've decided that maths is going to be the x variable. I suppose they call it in America, they call it math, don't they? Singular, because there's only one math, I suppose. And then English is the y variable. So what I've done is I've created a totals row down at the bottom here. So the totals row is just the sum of the values in each row. Okay, so the sum of the values in x is 33, the sum of the values in y is 38. I've then added 3 new rows here, and these 3 new rows are created from these 2 rows here. So this row here, x times y, okay, is called the cross product. Okay, so to calculate that, I'm just doing 4 times 6 to give me 24. Okay, and repeating that as we work our way down. And then this value at the bottom, okay, is the total of the cross products of x and y. Okay, then I've added another column called x squared. Okay, and x squared is just the value in x times itself. So 4 times 4 gives us 16, 6 times 6, 36, 7 times 7, 49, and so on. The same I've done with y squared as well. So we have 6 times 6 is 36, 7 times 7, 49, and then I've added another couple of totals down the bottom here, and those are the total of the x squared column and the y squared column. So we've managed to add quite a bit of data from our original data set, which was just the scores. So the number of entries that we have, we're going to use the letter n to indicate that. So n, the number of entries, is 5. Okay, so n equals 5, and here's our other totals here. Now, these numbers that I've written out, we have a sort of shorthand that we can write these with. So this is called sigma notation. Okay, sigma just means sum or sum up. Okay, so if I say the sum of n, okay, this just means the sum of all the values in the n column. The sum of n is 5. Okay, then sum of x is the sum of all the values in the x column. Okay, so sum of all the values in the x column is just the total of x. Okay, then we have this one, okay, which is the sum of x squared. And this is just x, the sum of x times the sum of x. So if we can work out the total of the x column here, the sum of x squared is just the sum of x times the sum of x. And that's exactly the same for y, okay? Then this one here, the sum of x, y, terrible arrow there, is the sum of the cross products column. Okay, so x times y all the way down. What's the total in that one? Then we have the sum of x squared. So the sum of the x squared column, and finally the sum of the y squared column. Okay, so we have the sum of the x squared column, the sum of the y squared column. So now we know what all those things are, we can work on plugging them into the formula. So I've rewritten the table, but instead of just writing totals, I've written the sigma notation beside each one. So this one here is going to be the sum of x. That's the sigma notation for that. This one's the sum of y. There's the sum of the cross products, the sum of x, y. There's the sum of x squared and the sum of y squared. Okay, so now that we know what each of those values are, we can put that into the formula. So the first thing we're going to do is calculate the numerator in the formula. So the top half of the formula, this part here. So if you imagine, right, n is 5, okay, so this is going to be 5, right? And then the sum of the cross products is 259, okay? So because it's in brackets, that means multiply, okay? So multiply that, and that's going to give us this number here, okay? Then what we're going to do is we're going to subtract that from the sum of x times the sum of y. So the sum of x is 33, sum of y is 38, and that gives us this number. And then we're going to subtract those, okay? So subtracting 1295, 1254 from 1295 gives us the answer 41. Okay, so if I just clear my annotations, you imagine this one's solved, okay, and it's 41. So at the moment, r is equal to 41 over this thing here. Okay, so the next step is we're going to solve this half here, these square brackets here. Okay, so the first step is to take the product of n and the sum of x squared. So the sum of all the values in the x squared column times 5. All right, so that's going to give us this number, 5 times 229, which gives us this. So that's 1145. 1145 is here. I should probably have written that underneath, actually. Hold on. So this is going to be 5 times 229, which means that is going to be 1145, okay, minus the sum of x times the sum of x. So we know that the sum of x is 229, so it was, sorry, the sum of x is 33. So 33 times 33 gives us this 1089. Take that away, and that leaves us with 56 here, okay? So the next thing to do is to solve this side of the equation. All right, so that's just doing the exact same thing we did with on the left side of the denominator, but just doing it with the y variables. So we're working out, first of all, the n times the sum of y squared. Okay, the sum of y squared column, the y squared column, the total of the y squared column, 5 times 289, giving us this value. And then we work out this over here, which is the sum of y times the sum of y, which gives us this, which gives us that. Then we take those two numbers away from each other, which gives us 46. All right, so this part of the equation is 46. Okay, so we've solved this part, and this part now. So now this looks something like r equals, okay, some value on the top, okay, divided by the square root of some value here times some value here. Okay, so this is a much easier to solve formula, obviously, than this thing here. Okay, so the next thing we need to do is just plug those values in. So placing the values in the formula. Okay, so what we're going to do is we're going to take 41, which was our answer for the numerator. Okay, so r is equal to 41, okay, over the square root of 56 times 46. Okay, so let me grab a calculator here. Let's show you how this can be worked out. So first thing we want to do is work out the square root of the bottom left values. So let's first of all do 56 times 46. Okay, that's going to give us 2576. Okay, so what we need to do is work out the square root of 2576. Okay, and that's going to give us this number, 50.754, a few decimal places. Okay, so all we now need to do is divide that 41, okay, divided by that gives us 0.8. And 0.8 is the correlation between the maths and English exam scores. So you can see that there's quite a strongly positive correlation between the two now that we've worked that out. Okay, there's a strong association between how good your score is on one test as it will be on the other. And we could say that those correlate at 0.8. Okay, there's a strong level of agreement between the two. Now, there's another value that we can work out quite easily from this, okay? And it's just this value times itself. Okay, so let me just copy that. If we do that times itself, okay, that gives us this. And this is called r squared, okay? It's just Pearson's r times Pearson's r, okay? And that gives us this number. This is the r squared number. And we can convert that to a percentage, okay? So once you've got Pearson's r, it's easy to work out r squared. All right, so r squared is called the coefficient of determination, and that's used in statistics as well. But once we've got Pearson's r, we can easily work out r squared. So an example for r squared would be when a woman gets pregnant, this has a direct relationship to when they give birth. Okay, and we can have the r squared value for that as a percentage. Now, unlike Pearson's r, okay, r squared is always a positive value, because when you square these negative numbers up, it comes out with a positive value. Okay, so it can be 0 up to 100%, the R squared. And the longer name for R squared is the coefficient of determination. So to find R squared once more, we take Pearson's R and we square it and we convert that value to a percentage. So if the correlation was 0.543, we square that value, okay, and that gives us this 0.295, and we can convert that to a percentage, which would mean 29.5 is the R squared value. That is the end of this topic. This week, the lab is divided into 2 tasks, one of which we're looking at the Python module pyplot. So I'll open that just now. Lab 7, and we're going to import a CSV. And this fun CSV is actually a Brazilian real to US dollar conversion. Okay, so you'll have to, where it says path, you'll have to troubleshoot that path there. Then we're going to import a library called pandas as PD. And then we're going to run this example, and it should give us a test graph as shown here. Okay, once we have all those pieces, we're going to put that all together into these questions. So we're going to get the data out of the CSV, and we're going to plot it into a similar graph here. And that is part 1 of the lab. Part 2 of the lab today is a correlation task. So thankfully, no Jupyter lab is required here. All you'll need is a spreadsheet, okay, and maybe a calculator, and maybe a piece of paper as well, and maybe some time to figure it out. So the first thing we're going to do is we're going to create a spreadsheet with this data set. Now, this data set has 2 variables. Okay, we have temperature and relative humidity. And this here is a timestamp. Okay, we can just consider this to be the n value. So we have 2021, okay, January the 14th, time midnight. Okay, 2021, January the 14th, time 1 a.m. Okay, this was the temperature, 0.7555026. So this is a real reading of how cold it actually was in January. So you certainly wouldn't be away to the beach at 1 a.m. With your shorts on if it was 0.75 degrees, okay? And the relative humidity was 94%. Okay, so that's quite a lot of moisture in the air. So we've got this data set here. All right, and what we're going to try and do is calculate the correlation between the temperature and the relative humidity. Okay, so we're going to take temperature as the X value and relative humidity as the Y value. All right, and what we're going to do is take this and put it into a spreadsheet, and that spreadsheet is going to look like this. Okay, so there's timestamp column, a temperature column, a relative humidity column. Once we're going to do that, we're going to calculate the X squared value, the Y squared value, the cross product, the product of X and Y. Then we're going to calculate the totals, so sigma of X, sum of Y, sum of X squared, sum of the Y squared values, sum of the cross products. Once we've done that, we're going to use these to calculate the correlation. So we're going to take all of those values and plug them in to the correlation coefficient formula that I've put here, and we're going to calculate the Pearson's R value. Okay, and once we've calculated R, we'll be able to calculate R squared as well. Okay, so once we've done that example, the next example I've taken from a game that some of you might have played. It's called WWF Super WrestleMania for the Sega Mega Drive, Sega Genesis, that cover is, which is the American name for the Mega Drive. But it was called the Mega Drive in Japan and here. So anyway, it was a good game, I promise you. If you didn't play it in 1993, I'll just remind you that it was good. So I've got some stats from that game. So we have Hulk Hogan is 6'7" and 320 pounds. And then we have some other wrestlers, the British Bulldog, Lex Luger, the Total Package, the Ultimate Warrior, and the Undertaker, Bret Hart. Okay, and we have each of their height and weight. Now, I was trying to come up with a height and weight kind of data set because that's quite a common correlation. If we think about like how BMI is calculated and stuff, but I didn't want to offend anyone. So I thought the best thing to do was just use a wrestling game from the early 90s. So the first task is we're going to convert the stats to the metric system. So convert 6 feet 10 to centimeters and convert the pounds value to kilograms. Okay, so that's step one. So what I would suggest is that you make a table just like this in a spreadsheet, okay, with the names in the first column, the height and weight in the imperial system, then the height and weight in the metric system. Then what we're going to do is we're going to assign height, the X value, and weight, the Y value, the Y variable. And then we're going to calculate X squared, Y squared, and the cross products, and then the totals of each of those columns. And then what we're going to do is we're going to use the formula to calculate R and R squared. And then we're going to say what the correlation is between the height and the weight of each of these wrestlers. Is it positive or is it negative? And if so, by how much? What's the answer? Okay.